Ethanal reacts with potassium cyanide followed by dilute acid to form 2-hydroxypropane nitrile. Name the mechanism for the reaction between potassium cyanide and ethanal. So without drawing the mechanism, because it's not asking us to do that, you just need to kind of know this. So this is nucleophilic addition. 2-hydroxypropane nitrile formed by the reaction in part A is a mixture of equal amounts of two isomers. Explain how the structure of ethanal leads to the formation of these two isomers. So A, B, and then C, draw the representation. Okay, so state the name of this type of mixture. So this is a racemic mixture. Okay, the explanation, so it is planar around the carbonyl in the molecule, and I'll just draw that over here. So it is flat, basically. Okay, so these are the marking points here. So there is equal chance of attack. By the nucleophile from above and below. Okay, so we can get attack from above, which will give you one of the optical isomers, attack from below, which will give you the other optical isomer. So both of which are equally likely, which is why you get this 50-50 mixture. Okay. So there's three of the marks. So we now need to draw the molecule for this. So now we started with ethanal. So CH3, CO8. So there's ethanal. When you attack this with cyanide, so we get cyanide attack on the top. So we're going to have a bond here, just working out here, and then the OH is formed where the carbonyl is here. Oops. So the four groups that I have to get on here, 1, 2, 3, 4. Now it's asking for a 3D representation, so I'm going to start with the tetrahedral structure. Okay, doesn't matter what order I put these in. So I'll do OH, CN, hydrogen and CH3, but I have to be aware of connectivity. Okay, so connectivity, got to make sure that bond there is pointing to that carbon, this bond here is pointing to that oxygen, this bond here is pointing to that methyl. Okay, I need to draw the mirror image of it. So the mirror image of this then, so carbon. So again, I've got OH at the top. I've got CN, but again, I've got to be careful of connectivity. And then I've got hydrogen here and CH3 there. So with my connectivity, again, I need to make sure that this bond here is pointing to that carbon, and to that oxygen there. Okay. Next part. 2-hydroxypropane nitrile can be used in the synthesis of the monomer acrylonitrile, and the structure of that is there. Suggest a suitable reagent for the conversion of 2-hydroxypropane nitrile into acrylonitrile. So the nitrile hasn't changed in here. So we're looking at the OH forming an alkene. So that's an alcohol to an alkene reaction. So I can use either concentrated phosphoric acid or concentrated sulfuric acid. The key thing here is the concentration, and I need to state that it has a high temperature. Okay, draw a section of the polymer showing 3 repeat units. Okay, so Let's just sort out one monomer first. Now, whenever we draw addition polymers, we start with the double bond, we move our bonds up and we move them down, and then we look at each carbon. So this carbon here has a hydrogen above and below. This carbon here has a hydrogen on one of them and then a cyanide on the other. So that is my monomer. And all I'm going to do is I'm going to draw 3 of these next to each other. So hydrogen, hydrogen, cyanide. Again, making sure I'm well aware of connectivity. Okay, and then I'm just going to join all these together. So remove the double bonds there, and then join that with that, that with that, that with that, and then there will be another one from here. Okay, so there we go.